My name is Jacob, and in this video series I'll guide you through the process of creating your first URcap. In this video we will develop the program node contribution. For the sake of demonstration we will create the light up URcap. In this case the URcap can be used to turn on a digital output on the robot for a given number of seconds before the output is turned back off. Recall that a URcap consists of a number of different Java classes. First, Polyscope calls the activator, and the activator registers the various services the URcap provides to Polyscope. The service will create the user interface, or view, and the contribution when these are needed. Looking at our contribution, the first thing we want to do is to complete our constructor. The constructor receives three arguments, respectively the program API provider, the view, and the data model. We want to save these as local instance objects that we can use later on throughout our class. To do so, we'll create a private final object for first the program API provider and call this API provider. Then for the view and call it view, and at last for the data model and call this model. Now we want to take the three arguments we get by the constructor and save these into these instance variables. To do this, we'll say this API provider equals to API provider. By using the term this, we reference the instance variable API provider, so the blue API provider here, while inside the constructor not using this will give us the local instance of the API provider. We'll repeat this process for the view and for the data model. So now all these three instance variables are initialized when the class is constructed. The next thing we want to do inside our contribution is that we want to tie our contribution and our view together. Inside our view we have two different controls, respectively an drop down for selecting which output to light up and a slider for selecting the duration. Whenever that is changed in the view, we want the view to notify the contribution. To allow this, we'll create two new public methods inside our contribution that the view can call. Hence we'll create a public void method that we can call on output selection. That takes a final integer argument called output. And subsequently for the on duration selection, we'll also take a final integer argument that we can call duration. For now, we will not add anything to these two callbacks from the view. We'll do that later, but we want to set up the view so it calls these two methods whenever something changes. To do that, we'll start by saving our contribution class and then open our view. Inside our view, we have two methods that respectively create the IO combo box and the duration slider. Both of these are implementing an event listener that listens to changes on these inputs, respectively an item listener for the combo box and a change listener for the slider. However, in order to get the appropriate contribution, we need to look at our build UI method. The build UI method gets a contribution provider object, and recall that there can be only one view class, but there can be multiple instances of the contribution if there are multiple nodes inside the program. Hence we need the contribution provider to provide the active contribution inside the view. So we need to provide this argument to our two creator methods. To do this, we'll add this as an argument, saying we'll add a final contribution provider, which is the light up program node contribution. We call this provider. Now we have this provider argument, and inside our item listener we can use our provider and say get. Calling get will return the active instance of our contribution, and here we can now call any of the public methods that are available inside our contribution class. In our case, we want to call the onOutput selection that we've just created. Here we want to ensure that we get an integer, so we will typecast the argument to integer, and then we'll use e.getItem to get the selected event. So in our item event, we'll say which item is it, typecast it to integer, and this is what we want to set inside our contribution. We'll repeat this process inside our duration slider method, also adding another argument, which is our contribution provider, and specifically the light up program node contribution. Now inside our state change listener, once again, we want to use our provider and call get, and then use onDurationSelection, where we want to pass in the new value that is read from the slider. So now our two methods here and our two item listeners will configure the settings appropriately in our contribution. Now we need to go back to our buildUI method and ensure that we also remember to pass in the provider argument, since we changed the signature of our two methods here. So we also need to make them reflect that. Now we can save our view and go back to our contribution, where our two methods here will be called whenever there is a change in the user interface. When the view is calling respectively onOutput selection or onDurationSelection, we want to store these values inside our data model. The data model is what we use to keep track of the settings for this particular node. However, when working with program nodes, it's also important to keep track of undo and redo. Polyscope will do this for us, but we need to be able to group our changes together as single undoable or redoable actions. And to do so, we need our undo redo manager. Hence we'll create a new instance variable for the undo redo manager and call it undo redo manager, and then initialize this inside our constructor. We'll do this by using our API provider and using our program API, and inside our program API we can find our undo redo manager. Now we can use our undo redo manager inside the onOutput selection to make our changes recorded. As we'll say undo redo manager and record changes. Inside record changes, we'll have to provide an undoable change object, which has one overridden method called execute changes. And inside execute changes is where we can actually store our values in our data model. When working in our data model, everything is stored by a key that identifies this particular parameter. So first, we want to create these keys as static class variables. Hence we'll create a private static final string, which we can call output key. And the particular key could just be output. We can do the same thing for our duration. And call this duration key. It's also very much recommended always to have a static default value for all of the parameters. We'll also create these as static class variables. We can call this default output and use the default output 0 or digital output 0 as our default. We'll do the same thing for our duration. And here we can use 1 second as the default value. Now we have our key for our data model. We want to store this inside our undoable changes whenever the onOutput selection is called. To do this, we'll take our data model, and then call set. Using set requires a key, and here is our output key and then the value. In this case, the value is the output provided by the method. We can do the same thing inside our onDuration selection by using our undo redo manager and record changes. Once again, creating a new undoable changes. And inside the execute changes method, we'll use our model and say set. The key here will now be the duration key, and the argument duration is what we want to store in our data model. So now every time the view has a change, it's going to call either on output selection or on duration selection, and we will group this change as one undoable action so the user can later use undo and redo, and it will be placed correctly on the undo redo stack. Now we've configured the situation where the view needs to set up values inside the contribution. But we also need to consider the situation where the contribution needs to configure the settings inside the view to make the user interface reflect the correct values. To do this, we'll start by creating getter methods where we can read the actual status from our data model, respectively for the output and duration. Hence we'll create a private integer method we can call getOutput. And here we'll return the value that we read from our data model by saying model get, and then the string key, in this case the output key. The default value in this case is the default output that we have already created. We want to do the same thing for get duration. Once again, we'll read the value inside our model by using the duration key and then the default duration. This means that if no value is set before, the model get will return the default value, but if the value is already configured, the actively configured value will be returned instead. Now we can use these two methods inside OpenView to configure the view. We already had the view object provided by our constructor, and we can use this to call, for instance, set IO combo box selection and then get output. Also, we can use view and then set duration slider and then get duration. This means that whenever the user enters the view and OpenView is called, we will configure the view to reflect the actually selected item in the combo box and the actually selected duration on our slider. However, In our case, the IO combo box will by default be empty. So we also need to configure the IO combo box to contain the appropriate items. There are in the UR control box 8 digital outputs of standard outputs in the controller. These are named from 0 through 7. Now we want to create a method that returns a list of these items, or a list of these outputs that the view can show. Hence we'll create a private method that returns an integer array. We can call get output items. And here we'll start by creating an integer array we can call items and make this a new integer with the length of 8. In order to fill the list of items, we'll create a for loop that simply iterates through the numbers 0 through 7 and adds them to the integer array. For every iteration inside our for loop, we will simply add the value I to the list of items, finally returning the items. Now we have a method that generates an integer array that we can use to define the outputs that are available, and we want to use OpenView to configure the IO combo box using set IO combo box items and then get output items. So now every time the user opens the view, we'll first define the combo box items, so the list of items, and then we'll set the actively selected one, followed by the value of the slider. If we look at the closed view, well, right now we're not starting any threads or similar dynamic processes in our open view, and hence there is nothing we need to stop again whenever the user navigates away and is no longer looking at the view. So for now, we can leave our close view method blank. And hence we've completed the binding between the view and the contribution, both allowing the view to save the settings in the contribution and allowing the contribution to configure the view whenever the view is opened. The next two methods that we have inside our contribution is respectively getTitle and isDefined. GetTitle reflects the name of the program node as shown in the program tree, as opposed to getTitle in the service, which is the name of the node in the structure list of all available program nodes. In our case, we want our getTitle to return a string that is light up, followed by a colon, then possibly DO for the digital output. And we can use get output, say light up DO3, for instance, if digital output 3 is defined. Then adding another string with space T equals, and then plus get the duration. Hence, if the node is configured to digital output 3 and a time of 4 seconds, the title will now read light up DO3 T equals to 4. And hence, getTitle is used to help the user navigate back to the appropriate node after multiple nodes are configured inside the program. IsDefined is another method. IsDefined should return true if the user has defined all the information that he needs to in order for the node to be able to successfully execute. If the user has to come back to the node and add more information, IsDefined should return false. In our case, we have chosen some reasonable default values, respectively digital output 0 and a duration of 1, which means that no matter if the user has not entered any values, the node will always be able to execute. Hence, in our case, for IsDefined, we want to return true. to signal to the user that our node is able to execute. Before creating the UR script, it's a benefit to consider what script code will actually do the job. This can be done by testing your proposed UR script first in Polyscope and by consulting the UR script manual. In our case, we want to turn on an output for a set duration and then turn it back off. According to the UR script manual, the command set standard digital out can be used to toggle a particular output to either high or low. And the sleep command can be used to spend a certain amount of time in seconds. Therefore, we can achieve the desired behavior by a script code where we execute a set standard digital out to true with the selected output number followed by a sleep command and then toggling the output back to false. Now we want to add our script code to the generate script method inside our contribution. In generate script, we get an argument called scriptwriter, and this is what we can use to append the script code that our node needs in order to execute the desired behavior at runtime. We can take this scriptwriter and use methods like append line, assign, and so on to have various script behavior. We want to start by using the writer append line, which takes a string argument, which would be a functional line of script code. In our case, we want to say set standard digital out, and then we want to read the output from our data model using get output, and then followed by a comma and then true to turn on the output and a parenthesis. Following this, we want to use our writer and use the sleep command and then read the duration as well from our data model. Finally, we want to turn off our output again using writer append line and then set standard digital out. Once again using the get output from our data model and comma false to turn the output back off again. Now inside our scriptwriter we are adding the 3 lines of script code that we need in order for our node to execute at runtime. Now we've completed the development of our contribution. Respectively, inside our contribution we have 2 public methods that the view can use to set up the appropriate settings whenever they're altered in the user interface. When the view is opened, the contribution will use OpenView to make the view reflect the settings that are stored in the data model of this node. We also use getTitle and isDefined to make it easier navigating the program tree for the user. And finally, we are generating the UR script required for our node to actually be functional at runtime. Now we have successfully developed our contribution. In the next video, we will build and deploy our URCap to Polyscope.